Let us discuss about star delta transformation technique. The given diagram shows it is a delta shape. Okay, this is a delta shape and this is actually Y shape. Okay, Y or it is also called as star type. So if I want to convert delta to star, sometimes they will ask for derivation. Derive expression for star to delta or delta to star. You should be very careful. You people are going to make a mistake. You are going to write opposite. So delta to star means given in input is delta and you have to convert into star. You have to write formula for RA, RB, RC. Now let us start with this. So in the given network, this is the delta network, this is star network. Let three nodes are A, B, C. Let A, B, C are the nodes, and between the same A, B, C nodes, let us write resistances. Between A and B, let me call as RAB. Between A and C, let me call it as a AC, RCA, and RBC. Between BC, RBC, between CA, RCA, between AB, RAB. And here, this is a star network from the midpoint. Here actually only one star now, only one. So let me call it as RA, which is connected to the B, RB, which is connected to the C is RC. Now, if this circuit and this circuit are equivalent, if this and this are equivalent, then what are the resistance appearing in delta between A and B should be equal to what are the resistance appearing from this. Okay, coming to this, if I consider this, if I consider delta, equivalent resistance, okay, the resistance between A and B node is RAB parallel with series combination of these two. So this RCA and RBC are in series because we are concentrating only on between A and B. Between A and B, RAB is one resistance, another is actually through this path. So in this reverse, RCA plus RBC are in series. So it is equal to RAB parallel with RBC and RCA. And if it is equal to this, if it is equal to this, between A and B, we have RA and RB. So these two are in series now. And this is not come into the picture because this end is C end is not at all connected. We are measuring resistance between A and B. So these two have some connection. Between A and B, we have some connection. And this is not at all connected to the terminal A and terminal B. So you have to ignore this. So it is RA plus RB in series. So RA plus RB must be equal to RA plus RB is star equivalent network equivalent resistance between A and B is RA plus RB. This should be equivalent to delta network equivalent resistance between A and B, which is RAB parallel with RBC RC. So that is equation number 1. Similarly, similarly, equivalent resistance between BC is RBC RBC parallel with these two. RBC between B and C, RBC is the only one resistance, and another two resistance are coming to through this RAB plus RCA. RBC parallel with RAB plus RCA. That is delta equivalent. And between this and this, we have RB plus RC. RB plus RC. So RB plus RC is equal to RBC parallel with RAB plus RCA. Similarly, for this branch, in this branch, equivalent resistance between A and C in star is equal to equivalent resistance between A and C in delta. So RA plus RC. RA plus RC is equal to RCA plus series combination of these two. RCA parallel with RAB plus RBC. So these three equations you have to write. Equation number 1, equation number 2, equation number 3. Between A and B, between B and C, between C and A. 1, 2, 3. So three equations we got. After that, equation 1 minus equation 2 you do. Equation 1 minus equation 2. Equation 1 minus equation 2 means RB will get cancelled. RA plus RB minus RB minus RC. So this term will get cancelled with this. RA minus RC is equal to this entire term minus this term. So this parallel with this one is R1 parallel R2 is R1 R2 divided by R1 plus R2. This into this divided by this plus this. Similarly, this parallel this is this into this divided by this plus this. So we wrote three equations. Now after that we are doing 1 minus 2. 1 minus 2 means B will get cancelled. We left with RA minus RC. We have RA minus RC. That is equation number 4. And we have RA plus RC. Equation number 3. So from this I can find RA because RA plus RC is this much. RA minus RC is this much. If I add 3 plus 4, RC will get cancelled. We will get 2 R times RA. Okay. So here RA minus RC denominator is same. RAB plus RBC plus RCA, that is called as sigma RAB. RAB plus RBC plus RCA, it is called as summation of this. This is sigma RA, or you can write this one only, no problem. Without writing the sigma RAB, you can write whole term. And here you are going to get RAB RCA will get cancelled. RAB RCA, RAB RBC, RAB RBC will get cancelled. We left with RAB RCA minus RBC RCA. Similarly, we got this expression RA minus RC. Here in the equation number C, we have RC plus RA. If I add equation 3 plus 4, then minus RC plus RC get cancelled. We left with 2 RA. We left with 2 RA. If I add this, 2 RA is equal to, denominator is anyway, once again it is same. Sigma RAB is nothing but RAB plus RBC plus RCA, and add it. RAB equation 3 plus 4, RAB RCA, RBC RCA, then RAB RCA minus RBC RCA. Minus RB RCA will get cancelled with plus RBC RCA. We left with 2 times RAB RCA. 2 times RAB RCA. And this 2 add cancel with this 2. So RA value is given by RAB into RCA divided by RAB plus RBC plus RCA. Please say here RA is equal to RAB plus RCA divided by sum of all. So how to remember this one is RA is equal to sum of adjacent, product of adjacent. So I want to find equivalent here. I want to find equivalent here. For this equivalent adjacent side, what is there? RAB and RCA. So RAB RCA opposite of these two divided by sum RAB plus RBC plus RCA. Similarly, I want to find here, that is RC. RC is equal to RCA into RBC, opposite adjacent of product of adjacent, RCA plus RCA into RBC divided by sum of all. Similarly, I want to find RB. To find RB, RAB into RBC, product of adjacent divided by sum of all. So that is the three equations we have to show. That is the answers for, what? Star, delta to star. So given delta values are RAB, RCA, RBC, we obtained expression for equivalent star connection. 2 star, delta 2 star, star equivalent. What is RA? You have to write. What is RB? You have to write. What is RC? You have to write. So that we got in terms of delta components. Now you have to write star to delta transformation. Star to delta opposite. So you can stop here only. If they ask only delta to star, you can stop here only. If they ask star to delta, then you can start from here. We know that. Okay, we know that in star to delta conversion, yeah, delta to star conversion, RA is product of adjacent. So this value is, that is middle one. RA is here. RA is product of these two. RAB into RCA divided by sum of all. That is equation number 1. And RB is product of these two. RAB into RBC divided by sum of all. And RC is product of these two divided by sum of all. So equation number 1, 2, 3. We know that. You can directly write that. After that, what you have to do is, okay, what you have to do is equation number, or you can consider this is equation number 5, 6, 7 only. These are nothing but 5, 6, 7. equation number 5, 6, 7. Now what you have to do is you can perform equation number 1 into 2 RARB plus 2 into 3 plus 3 into 1. Okay, or 5 into 6 plus 6 into 7 and 7 into 5. Or if you write it, these are equation number 1, 2, 3. These are equation number 1, 2, 3. You can write 1 into 2, 2 into 3 and 3 into 1. If you add this, you will get RARB. You will get RARB. Next RBRC. Next RCRA. If I add all this, denominator is same. In all the term, you have sum of all the resistance of this delta. Okay, it is if I multiply these two, if I multiply this to sigma RAB whole square, it is nothing but RAB plus RBC plus RCA whole square. It is nothing but RAB, RBC, RCA whole square. And you are going to get RAB, RCA, okay, plus RBC, RCA, RBC plus RBC, RCA. Denominator also you have to add. The numerators also you have to add. In all the term we have RAB. Here if I multiply these two, you are going to get RAB. If I multiply first and second, RAB is common. RAB square, RCA, RBC will get. Again, if I multiply these two, RBC square, RAB, RCA. Again, if I multiply these two, RCA square, RAB, RCA. In all the term, RA square, RBC square, RCA square you get. So you take one common. RAB plus RBC plus RCA common you take. RAB, RBC, RBC, RCA. If you take common, you will left with wherever square is there, no, that term will, in the first term RAB square was there, so RAB will left with. Next RBC square was there, we left with RBC. Next RCA square was there, no. Now this RA sigma RAB RBC will get cancelled with this square. This is whole square. This is only one term. This will get cancelled. Now we left with RAB plus RBC, RAB into RBC into RCA divided by RAB RBC RCA. That much sigma RAB. This is an important equation. After that, from equation you take any one equation. Which is that equation? From equation number 5. We can write RAB RCA as RAB RCA. Here A is there. Here also A is there. So RAB RCA divided by sum I can write as RA only. So here from these two, from RAB and RCA, okay, RAB and RCA, this product of these two RAB and RCA divided by all RAB RCA divided by whole thing can be written as RA, and we left with this. Only I will left with only this much. Okay, we left with RAB into RCA divided by whole. This full thing. This full thing is RA. We left with RBC. Similarly, and after that you divide throughout by RA. Divide throughout RA means we'll get RBC is equal to RA plus RB divided by RA. This will get cancelled. RA will get cancelled. RB by RB into RC divided by RA. RA by RC RA divided by RA. RA will get cancelled. So we left with RB, then RC, then RB, RC, RB, RC divided by RA. RBC is equal to RB plus RC, product of these two divided by remaining one. So how to remember here, you can see the given network is star. Star values are RA, RB, RC. I want to find delta equivalent. Delta equivalent RAB is equal to RA, this RA plus RB plus product of these two divided by this. RA plus RB plus RA, RB divided by RC. Similarly, this one RB plus RC plus RB into RC divided by RA. Next, this RAC, RA plus RC plus RA into RC divided by RE, RB. So this much you have to consider. So we are getting the answer as RBC is equal to RB plus RC, again product of these two divided by remaining one. RAC is RA plus RC, product of these two divided by remaining. RAB is RA plus RB plus RA into RB divided by RC. So this derivation is important. You can read once, at least you can do 50%.